Okay, Luke, thank you for taking your time for a
Simon.
conversation here in our podcast. We're at the Power to Drive conference, and I had just the pleasure to listen to your talk, as many others did. And yeah, you elaborated on many points in battery innovation that are important right now and will be of importance in the future. I would like to give us in our conversations the opportunity to highlight a couple of key points and also in detail discuss the one of or the other aspect. But before we dive into that, maybe you can elaborate briefly on who you are, where you're coming from, and what Electroder is providing to the field.
Sure. So, it's definitely, Simon, it's definitely a great pleasure to speak at the forum, also at your podcast, and a little bit about electroders. So we are World Economic Forum technology pioneers and focus on cell design and cell development.
Yeah.
So we will use virtual technology to accelerate the process for cell design and reducing the cost, improve the speed, and also improve the quantities. And this is a university spin-off companies. Making the research with a lot of research desks and also a lot of industrialization collaborations in both China and in Europe. We started the operated in China in Europe 5 years ago, based on our long collaboration with the German OEMs and the Chinese cell manufacturers. So I have a background of manufacturing, global manufacturing, and the battery industries, and now is just running our business here in Düsseldorf, Germany.
Ah, okay. All right. So you are located in Germany.
Yes, I moved here. Yeah.
And to summarize it with my words really quick, so you built up a lot of knowledge and competence in the battery industry due to the Asian expertise that has built over many years, and now supporting the European field, the European companies, on also accelerating their transition towards electromobility and battery innovation in that regard.
Yes.
Correct?
Yes, I think if you're looking back to 2012, lots of the battery cell development happens in China, and the manufacturers go through many challenges regarding to performance improvements, cost reductions, and integration of that. And there's lots of know-how accumulations. So that's why we developed this technology to virtually simulate the performance of the battery in terms of electrochemistries, thermal, and agings, so that to support and complement with trial and error. We're not trying to replace, testing. We're trying to making sure that people, when conduct trial and error, we're not randomly waste our chambers.
Simulation is important, but it cannot replace testing because the complexity and the interaction between, I mean, for me in my profession, between the product and the process, meaning the manufacturing process, how does it affect the product in the end? So that is a correlation that needs to be understood on various different domains, electrochemically, mechanically, from a production point of view.
Right.
But if we're only now talking about cell design, right? Even there, and I think you will elaborate a little bit on that, it's not sufficient to just build a mathematical model and an analytical model, because the interaction, electrochemicals, etc., are just too complex, correct?
I think the really we're trying to not replacing the trial and error, but we're trying to simulate early in the development phases so that we can rule out those directly wrong directions.
So that you can then test for what needs to be tested and not just randomly test everything.
Exactly. And also stimulate often, which means we can further mitigate the risk at each step of the stage gate of development. I think that has been proven very effectively in vehicle development of the V-shape frameworks. It's just in these areas of electrochemistry, the battery it relies on more solid physical models, more reliable solid models, and also not only the mechanisms, but also the models have been proven in the past to work in many mass-produced battery cells. And that's really where Electroder has the privilege to use our models in the past for many different type of applications. And only in this way that we are able to really build the physical model simulations in the development funnels to support data-driven decisions and right decisions in there.
And because the innovation is so fast at the moment, and as you also elaborated in your talk, the cell designs are changing year by year,
Yes.
or even month by month sometimes. You're also in the need of updating your models with the knowledge that is coming back from industry, right? As I understood, you're very close to the companies, the cell manufacturing companies, supporting on the cell design. So I assume that they will, to some extent, also provide you feedback so that you have input for your model building, so that you can then help them again improving their cell design in the second run of the iteration then.
Well, most of our physical models and are quite mature at this point because it has already, as I said, experienced a lot of different wide of the applications. And of course, we're seeing more different applications. High-speed chargings and all different is continue to be involved. But the fundamental of the model is pretty solid. We need to apply this to the infinite scenario to test it. Right? There are areas in new chemistries could be we need more validations to develop models. Some, for example, like aging mechanisms, understanding that it's a continuous efforts. It's continuous efforts. In that part, that we definitely are continue to evolve, but we don't rely on our customers' data to. We don't need that because this is not a data-driven model. We don't need to collect any data. This is really a physical mechanism model.
Okay, so analytical model, which is based up on your core physical assumptions.
Physical studies of it. So it's a harder.
Sorry.
It's actually take a lot of effort to develop and to validate and fine tune it. But the beauty of this, once it's becoming mature in terms of it, then it have a better good bandwidth boundary and very practical for cell design and cell development.
Yes, and it needs to have a thorough understanding of the physical fundamentals that are actually happening within the cell.
And also to add one point there is not only the importance of the physical model, but also packaging in a lot of know-hows in there. For example, the mechanical designs, or the build materials, or CEDs, or tolerance, and and a lot of the cell design know-hows are in very small areas. Packaging that in a flow-based use is also can reduce the barriers of usage and adoptions, and I think that's also very important for cell designs. Because we can't rely on everyone to be simulation experts. Most that people who really know the battery, know the products, are the engineers and the researchers in the battery fields, and that's why we build the tools to be towards for the most widely users.
So to facilitate the innovation process, the design process, to speak more specifically on, like you just mentioned, packaging, to have a tool at the hand where you can apply deep fundamental knowledge using a comprehensive dashboard, so to speak.
Yes.
I'm an mechanical engineer myself, and I know exactly what you mean when I'm having a CAD design tool at hand. Right? It's important that I can work visually with it, that it's fast, that I can use my engineering intuition built into it, but that the tool then translate my intuition to the domain that I'm working on, right? If it's the CAD model, into the physical design, then that I can manifest. If I'm doing a thermal design of a better cell, then it's being that use case. One thing that I'm interested in understanding, the buzzword of AI is around all the time at the moment, right? And you're just a prime example for, as I understood it, against this going with the flow and let AI run through everything, and you're playing thought and consideration, building an analytical model that you still can understand, correct? So I understand it this way. You're not creating a black box where you say like, hey, we train an AI and God knows what is in there, but it gives us some good results. But you're going the other route and saying, no, we build a straightforward model with all our physical know-how, physics, of engineering, etc., put it in that analytical model, and then we know exactly why we come to that conclusion in the end.
Yeah, let me try to answer your questions in two perspectives. Number one, definitely, you're absolutely right. That's what we're doing, and I think it's important because if we focus on accelerating the process, we need to be designed for manufacturing, because we're not designed for slides or good KPIs and performance on the paper. Eventually, we need to make that happen in the floor. And that's what I assist my customers a lot, is designed for manufacturing. So to do that, there's a lot of know-how that you need to keep in mind what are available to be manufactured, what are the available process, rather than just like AI to navigate, a perfect shape of design, but may not be actually in many cases can not be realized with machines or supply chain. I think. And from the other perspective, we do leverage AIs for our products. But the way we do it, we use it to optimize, to seek for the optimization designs. So we give them a boundary, and we tell them, okay, this is the power cells, and we give them a lot of boundaries for them to navigate it within the boundaries, rather than to have the AI to develop the models for us. The AI is proven to be very effective, efficient in seeking for or recommending what are the possible best solutions within your boundaries.
Okay, so a very dedicated use of AI in
Very
that regard.
dedicated. And also key to remember the things that's what
Are we talking about a short question? Machine learning AI systems, or what type of AIs do you implement there?
Yes, it's machine learning type of AIs, and also there are some minor technologies to complement it to make it better, dedicated to batteries. And I think we also, when talk about artificial intelligence, that we have lots of similar conversation in the World Economic Forum. It's about, my personal opinion is we use the technology to leverage and boost the capability of our engineers and researchers. We should not target to use this technology to replace what they do. So I think that this is very important. I believe the physical model plus the AI for optimization will actually help more people to do cell designs, to
make bigger steps.
That's what we need in Europe, right? So that's because on the one hand, we have one timeline for the electrification, and on the one hand, we're always short of personnel.
Yes. There are many voices in Germany and in Europe at the moment which say, like, our biggest issue is not that we are running behind battery innovation behind the Asians for a decade now, or even 2 decades probably, but that we don't have the personnel who's actually helping on accelerating our innovation at the moment, right? And that's why we were just talking about AI. Things along those lines are in such hot debate at the moment, because we're trying to elongate our arms and get more arms, basically, running to make up for the missing personnel.
Yes. I think on the one hand, we definitely need more people, more talents, more ideas in the field. On the other hand, I feel like we need to create an atmosphere for the people in this industry can make affordable mistakes.
Taking risk.
Taking risk.
You mentioned affordable risk.
Affordable risk.
Underline the state.
Because it's a must-have in the process of innovation. And companies and businesses or institutions should have a system to allow that happen. Because we have lots of talented people here in Europe, and it's everybody's job to create a system, an atmosphere for people to try out new things, try out new technology. That's very important, because you talk about catching up, right?
Yes.
And if we're using the same methodology, same technology of other companies have been developing batteries in the past decades, then how can we catch up in the same speed?
We're moving the same speed.
You're moving the same speed.
Running.
But
we are still running behind, not falling behind, but running behind.
But I think we do have a chance that we can, by using the right and the latest technologies, for example, the virtual simulations and virtual designs and other type of, all kinds of good stuff, and plus the capability to accept risk and failure as part of innovation, we can make a very difference. And Europe is second to no other regions in terms of developing better batteries in terms of performance and sustainability.
Oh, that's a compliment.
It is.
That is. So you see the European landscape, talking about the engineering competence, but also more the fundamental, the research competence out there, that if we get the right tools that you for example provide, to make those bigger steps, that by having this very unique big network of different cultures across countries, I mean, we're also quite a large community as such.
Yes.
So this valuable network, given the right tools, you're optimistic that we will have something to say in the battery innovation in the future.
I have good hope. I see a path.
That's good to know. That's good to know. Wow, I'm happy that you say that. In your talk, you mentioned different companies who are proposing different cell designs, from like blade batteries to maybe starting off with the cell design, cylindrical pouch, prismatic. Where do you see who's winning, who's taking which share?
Well, like I mentioned in the report, you can see from the data that pouch has been, narrowed down, and cylindricals is projected to go with bigger percentage, growing. But in the end, is what are the applications we're seeing, right? What are the there's no best format. There's
one solution.
Yeah, what are the application-specific cell requirement is this? I see a lot of activities in developing large prismatic today. I see a lot of activities in developing tabless cylindricals, which I'm personally involved with a lot. I see a lot of activities in leveraging pouch as a way to go solid state in the first phase. So each format has its own advantage in cell designs, and we should really look into what are the specific goals.
Yeah, and the specification also goes beyond e-mobility as such, because I saw in your presentation you made a differentiation between battery cells for mobile application
and ESS.
And then ESS.
Yes.
So stationary storage.
Yes. Yes. Exactly.
And the trends were a little bit different there, but in the same direction, I would say, or?
I think ESS, it's the most stationary commercial application. It's going, the cell is going bigger, right? We're seeing 280 ampere hours, and that's the majority, then 300 ampere hours. Now we're also seeing companies are releasing 500 or even 700.
Yes, yes. So which is quite large, by the way.
Safety is definitely, very important in cell design in that area. Yes. And I think the mobilities side, we're seeing more interesting innovations in terms of, cell minor improvements, and also the packings, and the cell to packs and type of stuffs. I think it's, in mobilities especially, we're also talking about different mobility is a big word. It includes, passenger cars, also have private load trucks, right?
Trucks, yeah.
Trucks, maritime, and
future aviation, probably.
Yeah, the aviation.
Their safety will be an even bigger issue.
Yeah. So it's just because it's very diverse. It asks for a different the type of requirements for all different type of cells.
Okay, good. If there is one thing that you just as a final remark would like to point us at, where you say like, hey, this is some innovation that I would like to mention because I think this will be of critical importance in the future.
I'm not being careful to make that statement, but I will see for companies who are doing cell designs and cell innovations in this field. Of course, in Europe now, I think we need to look into affordable, cost-optimized chemistries, because it's very important. It's not only related to the product, but also related to how to scale, just the scaling of it. So I think that's very important. Also, as you mentioned, the safety side of that, materials in there can play a role.
Okay, good. So in summary, we are looking towards big cells, either prismatic or pouch, but also tablet cylindrical cells. Safety will be of critical importance as we are entering different applicational fields which require bigger safety standards, such as marine applications, but especially also aviation. And what you mentioned, what I'm really happy to hear is that you see also the European landscape and battery innovation playing a critical role in the future, because there's much potential out there.
I think so, yes.
Okay, thank you.
Thank you. Second time.